Hello there and welcome to the Snoozy Scientist. I'm so grateful you found your way here tonight because we're about to embark on something truly special, a journey to our closest neighbor in space, that pale companion that's been watching over us since before there were eyes to watch back, the moon. Wherever you are right now, whatever brought you to this moment, let yourself settle in, take a breath, let your shoulders drop. Tonight, we're traveling to a world that's both impossibly distant and intimately close, a place that's been shaping our planet, our oceans, our very sense of time since the beginning. The moon is more than just a bright circle in the night sky. It's a storyteller, a timekeeper, a sculptor of tides and dreams. It's been a goddess, a destination, a mystery, and a mirror. And tonight, we'll explore it all together, slowly, gently, letting each wonder unfold at its own pace. Some of what you hear might surprise you, other moments might simply wash over you like moonlight through a window, soft and unhurried. And that's exactly how it should be. So find your most comfortable position, let the day fade behind you, and let's begin this slow, soothing journey through the world of the moon. 4.5 billion years ago, something catastrophic happened. Our Earth, still young and molten, still finding its shape in the chaos of the early solar system, was struck by another world. Imagine that for a moment. Not a small asteroid or a comet, but an entire planet, roughly the size of Mars, barreling through space on a collision course with our home. Scientists have given this ancient world a name, Theia, after the Greek titaness who gave birth to the moon goddess Selene. How fitting that the mother of the moon should be named for a titan of mythology, because what happened next was truly titanic. The impact must have been beyond comprehension. When Theia struck Earth, it didn't just leave a crater. The collision was so violent, so energetic, that both worlds partially melted on contact. Think of two water balloons colliding in slow motion, except instead of water, these balloons were filled with molten rock, iron, and the raw building blocks of planets. The impact sent enormous plumes of vaporized rock spiraling into space, along with chunks of both Earth and Theia's mantles. Some of this material fell back to Earth, some escaped into space forever, but a significant portion remained in orbit, a ring of debris circling our wounded planet, like the rings of Saturn, only made of molten droplets and rocky fragments instead of ice. And here's where something beautiful happened. Over time, perhaps just a few thousand years, which is merely a blink in cosmic terms, this ring of debris began to clump together. Gravity, that patient sculptor, pulled the fragments toward each other. Larger pieces attracted smaller ones. Slowly, piece by piece, collision by collision, the moon was born. Not as a separate world that wandered in from elsewhere, but as a child of Earth itself, formed from our planet's own substance mixed with the remains of Theia. This isn't just a theory scientists dreamed up over coffee. We have evidence, beautiful evidence, from the moon rocks brought back by the Apollo astronauts. When researchers analyzed the chemical composition and isotopes in these lunar samples and compared them to Earth rocks, they found something remarkable. The moon's material is eerily similar to Earth's mantle, far more similar than it is to Mars, Venus, or meteorites from elsewhere in the solar system. It's like finding out that someone is your sibling through a DNA test. The moon is quite literally made of Earth, a piece of us that broke away and became its own world. In those early days, the newborn moon was much, much closer than it is now. If you could somehow stand on the primordial Earth and look up, you'd see the moon looming enormous in the sky, perhaps 10 to 20 times larger than it appears today, filling a huge portion of the heavens. It would have been a spectacular, even terrifying sight. The tides it raised would have been monumental, not the gentle rises and falls we know today, but massive waves of water sweeping across the planet every few hours. The Earth itself would have been spinning much faster too, with days lasting only about 5 hours instead of 24. Everything was more intense, more dramatic, more raw. But from that violence, from that cosmic catastrophe, came something that would profoundly shape the story of our planet. The moon's presence would stabilize Earth's rotation, moderate our climate, create the tides that may have helped life emerge from the oceans. Some scientists even suggest that without the moon, complex life on Earth might never have developed. We are, in a very real sense, children of that ancient collision, just as much as the moon is. Now, you might be wondering, how do we actually know all this happened 4.5 billion years ago? Well, scientists have several clever methods. One involves examining the radioactive decay of elements in moon rocks. When rocks form, they trap certain radioactive elements inside them, and these elements decay into other elements at very precise, unchanging rates. By measuring how much of the original element remains and how much has decayed into something else, scientists can calculate when the rock solidified. It's like having a cosmic clock embedded in the stone itself, and those clocks tell us that the moon's oldest rocks formed about 4.5 billion years ago, shortly after the solar system itself began to take shape. There's something profoundly moving about holding a moon rock in your hand, which some fortunate researchers have been able to do. You're touching a piece of history that predates almost everything we know. These stones formed before life existed on Earth, before our oceans settled into their basins, before the first rain fell. They're older than any rock you'll find on Earth's surface, because our planet is geologically active, constantly recycling its crust through plate tectonics, erosion and volcanic activity. But the moon, cold and still, has preserved its ancient surface like a museum. Those rocks remember the solar system's youth. The moon orbits Earth at an average distance of about 384,400 kilometers, though this number fluctuates because the orbit isn't a perfect circle. Sometimes the moon comes a bit closer, what we call perigee, and sometimes it swings a bit farther away to apogee. This elliptical dance means the moon's apparent size in our sky changes slightly throughout the month. When it's closest, we get what popular media has dubbed a supermoon, which sounds dramatic but really just means the moon looks about 14% larger than usual. Still, there's something special about seeing our lunar companion at its biggest and brightest. The moon takes about 27.3 days to complete one orbit around Earth, but here's something interesting. That's not quite the same as the time from one full moon to the next, which takes about 29.5 days. Why the difference? Well, while the moon is orbiting Earth, Earth itself is orbiting the sun. So after the moon completes one circuit around Earth, our planet has moved along in its own orbit, and the moon needs a couple extra days to catch up to the same phase. It's like running laps on a track where the track itself is also moving. The 27.3-day period is called the sidereal month, measured against the background stars, while the 29.5-day period is called the synodic month, measured from one new moon to the next. What keeps the moon in orbit? It's a beautiful balance between two forces. The moon's velocity wants to fling it off in a straight line into space, but Earth's gravity constantly pulls it inward, curving that straight path into an ellipse. Think of it like swinging a ball on a string. Your hand pulling the string inward is like Earth's gravity, and the ball's desire to fly away represents the moon's orbital velocity. As long as these two forces balance, the moon stays in orbit, never falling to Earth, never escaping into deep space, just endlessly circling in that patient, rhythmic dance it's been performing for billions of years. But this balance is slowly changing. The moon is actually moving away from Earth, bit by bit, year by year. We'll explore why later. But for now, just know that this slow drift means the moon's orbit is very gradually expanding. The rate is tiny, about 3.8 centimeters per year, roughly the same rate your fingernails grow. You certainly won't notice it in a lifetime, or even in 1,000 lifetimes, but over hundreds of millions of years, it adds up. Dinosaurs saw a moon that was noticeably closer than the one we see today, and billions of years in the future, if humans or our descendants are still around, they'll look up at a moon that's smaller and more distant. There's something both sad and beautiful about that, isn't there? Even our eternal companion, our constant friend in the night sky, is slowly moving away. But let's not get ahead of ourselves. The moon will be with us for a very, very long time yet. Here's something that puzzled ancient astronomers and still surprises many people today. The moon doesn't seem to spin. If you watch the moon night after night, month after month, you'll always see the same features, the same dark patches, the same bright highlands, the same pattern of craters. It's as if the moon is frozen, showing us the same face forever. But here's the thing, the moon absolutely does rotate. It spins on its axis once every 27.3 days, which is, not coincidentally, exactly the same time it takes to orbit Earth once. This perfect synchronization means that the same side always faces Earth. This phenomenon is called tidal locking, and it's not unique to our moon. Many moons in the solar system are tidally locked to their planets. But how does this happen? Why would the moon's rotation slow down to match its orbit so precisely? The answer lies in the very force we mentioned earlier, tides. We usually think of tides as something that happens to our oceans, but Earth's gravity also raises tides in the moon itself. Early in the moon's history, it was still hot and partially molten, and Earth's gravity would create bulges in the moon's body, pulling the near side toward Earth and raising a corresponding bulge on the far side. As the moon rotated, these bulges would try to stay pointed at Earth, creating friction within the moon's interior. This friction gradually slowed the moon's rotation over millions of years, until it reached the current state where one rotation takes the same time as one orbit. Once that happened, the same side always faced Earth, the bulges no longer had to move, and the friction stopped. The moon had settled into its most stable configuration. You can demonstrate tidal locking with a simple thought experiment. Imagine you're waltzing with a partner, and you want to keep facing them the entire time as you circle around. To do this, you have to rotate once for every circle you make. That's exactly what the moon does with Earth. It rotates once per orbit, so it can keep the same face toward us. This means there's an entire hemisphere of the moon we can never see from Earth. Well, almost never. There's a slight wobble in the moon's motion called libration that lets us peek a bit around the edges over time, so we can actually see about 59% of the moon's surface from Earth if we watch it over many months. But there's still a substantial portion, about 41%, that remained completely hidden from human eyes until the space age. Ancient astronomers had no idea what was on the far side, they could only imagine. The far side of the moon is often incorrectly called the dark side, which sounds mysterious and appealing but isn't quite accurate. Both sides of the moon receive equal amounts of sunlight over time. When we see a new moon, the far side is actually fully illuminated, basking in sunlight, while the near side faces us in darkness. And when we see a full moon, the near side is lit while the far side is dark, so the far side isn't perpetually dark, it's just perpetually hidden from Earth's view. But it is quite different from the near side in some fascinating ways. When Soviet spacecraft first photographed the far side in 1959, sending back grainy images that humans had never seen before, scientists were surprised. The far side has far fewer of the dark, smooth areas we call Maria, Latin for seas. These Maria, which dominate the near side and give the moon its familiar face, are actually ancient lava flows that filled giant impact basins billions of years ago. But on the far side, the crust is thicker, and when asteroids struck there, they didn't punch through to the molten interior as easily, so less lava flowed out to fill the craters. The result is a surface that's much more heavily cratered, much rougher and more ancient looking. Why is the far side's crust thicker? Scientists think it might be related to the moon's formation and early cooling. When the moon first solidified, the side facing Earth was kept warmer by Earth's heat, while the far side facing cold space cooled faster and formed a thicker crust. It's like how water freezes faster at the surface of a pond than at the bottom. The temperature difference created a permanent asymmetry in the moon's structure. The far side also contains the largest and deepest known impact crater in the solar system, the South Pole Aitken Basin. This tremendous scar is about 2,500 kilometers across and 8 kilometers deep. To put that in perspective, you could fit the entire United States inside it with room to spare. The impact that created this basin must have been staggering, possibly punching almost all the way through the moon's crust. Some scientists theorize that this impact might have brought deep subsurface material to the surface, giving us a window into the moon's interior. Studying this basin could tell us much about the moon's composition and history. Standing on the far side of the moon would be a uniquely isolating experience. You'd be the only person, perhaps the only conscious being, in the entire solar system who couldn't see Earth. Every human who has ever lived, with the exception of the Apollo astronauts who orbited around to the far side, has always been able to look up and potentially see the moon, but from the far side, Earth is forever hidden, blocked by the entire mass of the moon itself. You'd be truly alone with the stars, cut off from home in a way that's hard to imagine. The far side is also the quietest place imaginable in terms of radio noise. Earth is constantly buzzing with radio transmissions, TV signals, Wi-Fi, cell phones, all creating a constant electromagnetic chatter. But on the far side of the moon's body blocks all of that. The radio silence is absolute. Some astronomers dream of building radio telescopes there, where they could listen to the faintest whispers of the early universe without any interference from our noisy civilization. Only a handful of humans have ever seen the far side with their own eyes. The Apollo astronauts who orbited the moon. They described it as rugged, forbidding, and deeply alien. Even though they trained on near-side photographs, nothing prepared them for the dramatic difference. It was like discovering that a familiar friend had a secret, completely different face they'd never shown you. Let's talk about one of the moon's most profound influences on our world, the tides. Twice a day, the oceans rise and fall in a rhythm that has remained constant for billions of years. Coastal dwellers organize their lives around this rhythm. Fishermen time their voyages by it. Creatures in tidal zones have evolved their entire life cycles to match it. And all of it, every single tide, is choreographed by the moon. Here's how it works. The moon's gravity pulls on Earth, but crucially, it doesn't pull equally on all parts of Earth. The side of Earth facing the moon is closer to it, so it feels a stronger gravitational pull than the center of Earth does. And the center of Earth feels a stronger pull than the far side. This difference in gravitational force across Earth's diameter is called a tidal force, and it's what creates the tides. Now you might think this would create one bulge of water on the side facing the moon, and you'd be half right. There is indeed a bulge on the moon facing side where the water is pulled toward the moon, but there's also a bulge on the opposite side of Earth, and the reason for this is wonderfully subtle. The center of Earth is being pulled toward the moon more strongly than the far side water, so in a sense, Earth is being pulled away from that far side water, leaving it behind. The result is two bulges, one on each side of Earth, with low water in between. As Earth rotates underneath these bulges, any given location experiences two high tides and two low tides each day. But wait, there's more complexity. The sun also creates tides, about half as strong as the moon's. When the sun and moon align during new and full moons, their tidal effects add together, creating extra high spring tides and extra low lows. When the sun and moon are at right angles to each other during the quarter moon phases, their effects partially cancel out, creating more moderate neap tides. So the strength of the tides follows a monthly cycle that mirrors the moon's phases. The actual behavior of tides gets even more complicated because the continents get in the way. The oceans can't just flow freely around the whole planet. Instead, tidal bulges have to squeeze between landmasses, pile up in bays, and slosh around in ocean basins. Some places, like the Bay of Fundy in Canada, experience tidal ranges of over 16 meters, the water level changing by the height of a 5-story building twice a day. Other places, like the Mediterranean Sea or the Baltic Sea, barely have noticeable tides at all because of their geography. Each coastline has its own unique tidal personality. For billions of years, the tides have been mixing the oceans, bringing nutrients up from the depths, creating dynamic environments where life could thrive. Some scientists believe that tidal pools, those small pockets of water that get regularly mixed between ocean and land, may have been crucibles for early life. The tides would concentrate organic molecules, provide energy through their constant motion, and create ever-changing chemical conditions that could spark the reactions needed for life to begin. In this view, we owe our very existence to the moon's gravitational embrace. But here's something that might surprise you. Tides don't just affect water. Earth's crust itself rises and falls with the tides, flexing up and down by as much as 30 centimeters, roughly a foot, twice daily. The entire planet breathes with the moon's influence. though we're too small and the motion too slow for us to notice. Even the atmosphere experiences tides, though they're subtle and mixed with weather patterns. And remember earlier, when I mentioned the moon is slowly drifting away from Earth, the tides are responsible for that too. Here's the mechanism. As Earth rotates underneath the tidal bulges, friction between the moving water and the ocean floors tries to drag the bulges along with Earth's rotation. This means the bulges aren't perfectly aligned with the moon, but are carried slightly ahead of it. Now these offset bulges have their own gravitational pull on the moon. The bulge on the near side is closer to the moon, so it pulls harder than the bulge on the far side, and because it's been dragged ahead of the moon, that pull has a component that's in the direction of the moon's orbital motion. This very slightly speeds up the moon in its orbit, and when an orbiting object speeds up, it moves to a higher orbit, farther away, so the moon is gradually stealing rotational energy from Earth through the tides, slowing Earth's spin, and using that energy to boost itself into a higher orbit. This is actually measurable. Scientists can bounce laser beams off mirrors left on the moon by Apollo astronauts and measure the time it takes for the light to return. By doing this repeatedly over years, they've directly confirmed that the moon is receding at about 3.8 centimeters annually, and careful atomic clocks have confirmed that Earth's day is getting longer, at a rate of about 1.7 milliseconds per century. These two changes are connected, a slow exchange of angular momentum that's been happening since the moon formed. If we extrapolate backward, we find that billions of years ago, the moon was much closer, and Earth was spinning much faster. Days were only a few hours long. The moon appeared enormous in the sky, and the tides. Oh, the tides would have been spectacular. Tremendous waves reshaping the coastlines multiple times per day. As we extrapolate forward, eventually, billions of years in the future, Earth's rotation will slow down enough that one day will equal 1 month. At that point, Earth will be tidally locked to the moon just as the moon is tidally locked to Earth. The same side of Earth will always face the moon, and from that hemisphere, the moon will appear to hang motionless in the sky, never rising or setting. From the other hemisphere of Earth, the moon will never be visible at all. It's a strange future, though it's so far away that the sun will have changed dramatically by then, so who knows what Earth will actually be like. When you look up at the moon, you might notice it's not uniformly bright. There are darker regions and lighter regions that form patterns. These patterns have inspired countless myths and stories. Some cultures see a man in the moon, others see a rabbit, a woman, a toad, or a face. What we're actually seeing is a mix of two different types of lunar terrain. The bright areas are called highlands, and they're the moon's original ancient crust, made of a rock called a northocite. This rock is light-colored and dates back to the moon's earliest days, when its entire surface was covered in a molten ocean of magma. As this magma ocean cooled, lighter minerals floated to the top and solidified into the highland crust. These bright regions are heavily cratered because they're old, and they've been exposed to billions of years of asteroid and comet impacts. The dark regions are called maria, which again means seas in Latin. Early astronomers thought they might actually be bodies of water, which they're not. They're actually vast plains of solidified lava, basalt rock, that's darker than the highland material. These maria formed between about 3 and 4 billion years ago, when enormous asteroids punched through the lunar crust, and lava welled up from the interior to fill the resulting basins. The lava flows were enormous, in some cases covering hundreds of thousands of square kilometers, and reaching depths of 1 kilometer or more. But because they formed after most of the heavy bombardment had ended, they have fewer craters than the highlands. They represent a younger chapter in the moon's history. The maria have wonderful names, given by those early astronomers who thought they were actual seas. Mare Tranquillitatis, the Sea of Tranquility, where Apollo 11 landed. Mare Serenitatis, the Sea of Serenity. Mare Imbrium, the Sea of Rains. Mare Nubium, the Sea of Clouds. He of Clouds. These names evoke poetry and peace, even though the maria formed in violence, blasted out by some of the largest impacts the moon has ever experienced. Then there are the craters. Oh, the craters. The moon's surface is absolutely covered with them, ranging from tiny pits smaller than a millimeter across to enormous basins hundreds of kilometers in diameter. Every crater tells the story of an impact, a piece of debris from the early solar system that ended its journey by slamming into the moon. The moon has preserved these scars because it has no atmosphere to burn up incoming objects, and no geological activity to erase the craters over time. It's a museum of impacts, a record of the solar system's violent youth that Earth has lost through erosion and plate tectonics. Some craters are simple bowl shapes, while others are complex structures with terraced walls and central peaks. The largest impacts created such massive excavations that the crater walls collapsed inward, forming terraces like a stepped amphitheater. The central peaks formed when the compressed rock beneath the impact site rebounded, like water splashing back up after a stone is dropped in. Some craters have bright rays extending outward from them, long streaks of ejected material that were thrown out during the impact. These rays can stretch for hundreds of kilometers across the lunar surface. The crater Tycho, one of the most prominent on the near side, has rays that reach almost a third of the way around the moon. Walk into any crater and you'd find yourself in a world of sharp contrasts. Without an atmosphere to scatter light, shadows are utterly black, while sunlit areas are blazingly bright. There's no softness, no gradation, just stark boundaries between light and dark. The dust covering everything is incredibly fine, pulverized by billions of years of impacts into a powder finer than talcum, and it smells, surprisingly. Apollo astronauts reported that when they came back inside their lunar module after moonwalks, the dust they tracked in smelled like gunpowder or wet ashes. This is because the dust particles, broken down at the atomic level and unweathered by air or water, have exposed chemical bonds that react with the moisture and oxygen in the spacecraft's cabin. The dust also clings to everything because there's no moisture to clump it together, and it's electrostatically charged by the solar wind and ultraviolet radiation. It was one of the biggest nuisances the Apollo astronauts dealt with. It got into equipment seals, scratched helmet visors, and was nearly impossible to clean off spacesuits. Future lunar explorers will have to contend with this clingy, abrasive dust as one of their major challenges. Looking at the moon in the night sky, it's easy to think of it as a light source, something that glows on its own. But the moon doesn't produce any light. Every bit of illumination we see is reflected sunlight. The moon is a mirror, though not a particularly good one. It reflects only about 12% of the sunlight that hits it, a property called albedo. The rest is absorbed and eventually re-radiated as heat. For comparison, Earth reflects about 30% of incoming sunlight because of our clouds and ice caps. Venus, shrouded in bright clouds, reflects about 75%, but the moon's surface is relatively dark, made of rock that's been darkened further by eons of exposure to space. The sun illuminates the moon from different angles as the moon orbits Earth, which is what creates the phases. When the moon is between Earth and the sun, the side facing us is dark. That's a new moon. As the moon moves in its orbit, more and more of the sunlit side becomes visible to us, creating the waxing crescent, first quarter, and waxing gibbous phases, until the moon is opposite the sun in the sky, and we see the fully illuminated face, the full moon. Then the process reverses through waning gibbous, last quarter, and waning crescent phases, until we're back to new moon again. It's a cycle that takes about 29.5 days, as we discussed earlier, and it's been one of the most reliable timekeepers available to humanity throughout history. Here's something beautiful. The same amount of the moon is always illuminated by the sun, except during a lunar eclipse. Half of the moon is always in sunlight and half in darkness, just as half of Earth always is. What changes is which part of that illuminated half we can see from Earth. During a new moon, we're looking at the dark half. During a full moon, we're looking at the lit half. During the quarter moons, we see exactly half of the lit half, which is a quarter of the total lunar surface. The geometry is perfectly logical, yet it took humans many centuries to fully understand it. The moon's surface temperature varies wildly depending on whether a spot is in sunlight or shadow. In direct sunlight, temperatures can reach about 127 degrees Celsius, hot enough to boil water, but in shadow, temperatures plummet to minus 173 degrees Celsius. That's a temperature swing of 300 degrees, far more extreme than anything experienced on Earth. This happens because the moon has no atmosphere to transport heat or moderate temperatures. Heat can only move through direct contact between rocks or through radiation, and rock is a poor conductor, so just a few centimeters below the surface, the temperature is fairly constant, but at the surface itself, it's either scorching or freezing depending on whether the sun is shining. When moonlight reaches Earth, it's soft and gentle, nothing like the harsh glare of the sun. There's something peaceful about moonlight, something that's inspired poets and lovers for millennia. Walking in the moonlight feels different from walking in daylight. Colors are muted, shadows are softer. The world takes on a silvery quality, dreamlike and mysterious, and yet that gentle glow is just sunlight, the same photons that warm our days, but reflected off ancient lunar rock and slightly reddened in the process. The moon adds nothing but changes the character of the light, completely simply by reflecting it. A full moon is about 400,000 times dimmer than the sun, which sounds like a lot until you realize that if you stood in full moonlight, you're receiving only about 1/millionth of the light you'd get from the sun. That's why moonlight can't give you a sunburn or even a tan. It's not strong enough. But it's strong enough to read by if your eyes are adjusted, strong enough to cast your shadow, and strong enough to light your way on a dark night. Before electric lights, people planned activities around the moon's phases, traveling and working outdoors when the moon was full, because the extra light made nighttime tasks safer and easier. Every so often, Earth, Moon and Sun align in such a way that shadows become cosmic events. These are eclipses, and they're among the most spectacular sights nature offers. There are two types: lunar eclipses, when Earth's shadow falls on the moon, and solar eclipses, when the moon's shadow falls on Earth. Lunar eclipses happen during a full moon, when the moon passes through Earth's shadow. You might think this would happen every full moon, but it doesn't, because the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. Most of the time, the moon passes slightly above or below Earth's shadow, but a few times a year, the alignment is just right, and the moon slides into the shadow. Earth's shadow has two parts: the umbra, the dark inner shadow, where Earth completely blocks the sun, and the penumbra, the lighter, outer shadow, where Earth only partially blocks the sun. When the moon enters the penumbra, it dims slightly, though the effect is subtle. But when it enters the umbra, the dimming is dramatic. The moon can take on a deep copper or reddish hue during a total lunar eclipse. This happens because even though Earth is blocking direct sunlight, some light bends through Earth's atmosphere around the edges of our planet. This light is reddened by passing through the atmosphere, the same effect that makes sunsets red, and this dim reddish light is what illuminates the moon during totality. The exact color depends on how much dust and cloud is in Earth's atmosphere at the time. A dusty or cloudy atmosphere filters out more light, making the moon appear darker and redder. Lunar eclipses are safe to watch with the naked eye, and they can be seen from anywhere on Earth's night side. They can last for several hours, with totality, the period when the moon is completely in the umbra, lasting over an hour. It's a slow, stately event, perfect for watching with a warm drink as the moon changes color overhead. Solar eclipses are a different beast entirely. They happen during a new moon, when the moon passes directly between Earth and the sun, casting its shadow onto Earth. But here's something remarkable. The moon is about 400 times smaller than the sun, but it's also about 400 times closer to Earth than the sun is. This cosmic coincidence means that the moon appears almost exactly the same size as the sun in our sky. No other moon in the solar system has this property. It's utterly unique to Earth. When the alignment is perfect, and the moon is close enough to Earth in its elliptical orbit, the moon can completely cover the sun's bright surface, creating a total solar eclipse. For a few precious minutes, day becomes night, stars appear, the temperature drops, birds stop singing, and the sun's corona, its outer atmosphere becomes visible as a pearly white halo around the dark disk of the moon. It's one of the most awe-inspiring sights in nature, and people travel thousands of miles for a chance to stand in the moon's shadow. But that shadow is small, rarely more than a couple hundred kilometers wide, and it races across Earth's surface at over 1,000 kilometers per hour as the moon orbits. If you're outside the path of totality, you might see a partial eclipse where the moon takes a bite out of the sun, but you miss the full drama of totality. Total solar eclipses are rare for any given location, happening on average once every 375 years. But somewhere on Earth, a total solar eclipse occurs about every 18 months. When the moon is farther from Earth in its orbit, it appears slightly smaller and can't completely cover the sun. The result is an annular eclipse, where a ring of sunlight remains visible around the moon. These are beautiful but lack the drama of totality, because the sky doesn't darken completely, and the corona doesn't become visible. Ancient peoples understandably found eclipses frightening. The sun or moon being devoured by shadow was often interpreted as a terrible omen. Many cultures developed myths about dragons or demons eating the celestial bodies. Once the geometry was understood, however, eclipses became predictable. Ancient Babylonian astronomers noticed that eclipses follow a pattern called the Saros cycle. After 18 years, 11 days and 8 hours, the Earth, Moon, and Sun return to nearly the same geometric relationship, and eclipses repeat in similar patterns. Using this knowledge, astronomers could predict eclipses years in advance. One of the most famous eclipse predictions was made by the Greek philosopher Thales, who reportedly predicted the solar eclipse of May 28, 585 BCE. According to the historian Herodotus, this eclipse occurred during a battle between the Lydians and the Medes, and the sudden darkness so frightened both armies that they stopped fighting and made peace. Whether the story is entirely accurate or embellished, it shows how profoundly eclipses could affect ancient peoples. The solar eclipses have also been scientifically valuable. During the total solar eclipse of 1919, astronomers measured the positions of stars near the sun and found that their apparent positions were shifted exactly as predicted by Einstein's theory of general relativity. The sun's gravity was bending the starlight passing near it, and the eclipse provided the rare opportunity to see stars close to the sun's position in the sky. This observation made Einstein world famous and provided crucial evidence for his revolutionary theory. Before humans had mechanical clocks, calendars, or electronic devices, they had the moon. The moon's phases are obvious, regular, and impossible to miss. It's no wonder that almost every ancient culture used the moon to measure time. A lunar month, from new moon to new moon, lasts about 29.5 days, which is a very natural unit of time. 12 lunar months make about 354 days, which is close to but not quite the same as a solar year of 365 days. This created a perpetual challenge for ancient calendars. Do you follow the moon and drift out of sync with the seasons, or do you follow the sun and lose the simple beauty of lunar months? Different cultures made different choices. The Islamic calendar is purely lunar, with 12 months of 29 or 30 days each, adding up to 354 or 355 days per year. This means Islamic months drift backward through the seasons, completing a full cycle every 33 years or so. The holy month of Ramadan, for instance, occurs at different times of the solar year across the decades, sometimes in summer, sometimes in winter. The Jewish calendar and the traditional Chinese calendar are lunisolar, meaning they follow lunar months, but periodically add an extra month to stay synchronized with the solar year. It's a compromise that keeps both the moon's phases and the seasons aligned. The Hebrew calendar adds 7 extra months over a 19-year cycle, a system that was also used in ancient Babylonian and Greek calendars. The calendar most of the world uses today, the Gregorian calendar, is purely solar, ignoring the moon entirely, except for the calculation of Easter, which still depends on the first full moon after the spring equinox. But the structure of our calendar bears the moon's fingerprints. The word month itself comes from moon, and the 7-day week, while not directly related to lunar phases, may have originated from the division of the lunar month into 4 roughly equal parts, corresponding to the new moon, first quarter, full moon, and last quarter. Many agricultural societies timed their planting and harvesting by the moon. Some of this was based on practical observation. The full moon provides light for working at night, while some was more mystical, beliefs that certain phases were better for certain crops. Native American tribes gave evocative names to each full moon throughout the year: the wolf moon in January, the snow moon in February, the worm moon in March when earthworms emerge, the pink moon in April named for pink wildflowers, the flower moon in May, the strawberry moon in June, the buck moon in July when deer antlers grow, the sturgeon moon in August when these fish were abundant, the harvest moon in September, which provided extra light for harvesting crops, the hunter's moon in October, the beaver moon in November, and the cold moon in December. These names connected the passage of time to the natural world and the moon's rhythm. The moon also provided navigation for travelers long before GPS or even magnetic compasses were reliable. Knowing the moon's position and phase could help sailors estimate their latitude and the time of night. A full moon rises at sunset and sets at sunrise. A first quarter moon rises at noon and sets at midnight. A last quarter moon rises at midnight and sets at noon. These patterns are consistent and dependable, making the moon a clock in the sky. Throughout human history, the moon has been sacred, mysterious, and powerful. To nearly every ancient culture worshipped lunar deities or incorporated the moon into their mythology and religion. These stories reveal how deeply the moon has been woven into human consciousness. In ancient Mesopotamia, the moon god was called Sin or Nana, and he was considered one of the most important deities, the father of the sun god Shamash. The great ziggurat at Ur was dedicated to Nana, and the Sumerians believed the moon's phases represented the god's changing fortunes and moods. The ancient Egyptians associated the moon with Thoth, the god of wisdom, writing, and magic, often depicted with the head of an ibis and a crescent moon on his head. Thoth was said to have won extra days for the year by gambling with the moon, which is why the year has 365 days instead of 360. The Egyptians also associated the moon with Khonsu, whose name means traveler, referencing the moon's journey across the sky. Greek mythology gave us Selene the Titaness, who drove her moon chariot across the night sky. She was the sister of Helios the sun and Eos the dawn. One of the most beautiful myths tells of Selene's love for Endymion, a handsome mortal shepherd. Selene fell so deeply in love that she asked Zeus to grant Endymion eternal life. Zeus agreed, but put Endymion into an eternal sleep. Every night, Selene visits her sleeping lover, which is why the moon appears to wander through the sky, searching. The Romans called her Luna, from which we get words like lunar and lunatic, the latter reflecting the ancient belief that the moon could affect mental states. Many Asian cultures saw a rabbit or hare in the moon's markings. In Chinese mythology, the moon rabbit, or jade rabbit, lives on the moon and pounds herbs with a mortar and pestle, creating the elixir of immortality. The story goes that the rabbit was placed there by the gods as a reward for its selflessness. Similarly, Japanese and Korean folklore feature a moon rabbit making mochi or rice cakes. These stories are charming and reflect how different cultures interpreted the same visual patterns in entirely different ways. Norse mythology featured Mani, the personification of the moon, who was chased across the sky by a wolf named Hati. During a lunar eclipse, it was believed that Hati had finally caught Mani and was devouring him, and people would make noise to scare the wolf away. This myth beautifully explains both the moon's motion and eclipses within the framework of Norse cosmology. Hindu mythology associates the moon with Chandra, a deity who rides a chariot pulled by 10 white horses or a single antelope. The moon's waxing and waning was explained by a curse. Chandra married the 27 daughters of the king Daksha, representing the 27 days the moon takes to move through the zodiac, but he favored one wife, Rohini, above all others. The other wives complained to their father, who cursed Chandra to waste away. Chandra pleaded, and Daksha modified the curse so that Chandra would waste away for half the month, but then regain his strength for the other half, creating the lunar phases. In many Native American traditions, the moon was often seen as female and associated with fertility, crops, and the rhythms of nature. Some tribes told stories of moon and sun as siblings or spouses, explaining day and night as their eternal dance. Other stories explained the moon's markings as the face of a woman or as evidence of various adventures. The Maori people of New Zealand tell the story of Rona, a woman who was on her way to fetch water by moonlight when clouds obscured the moon, causing her to trip and curse the moon. Offended, the moon reached down and pulled Rona, along with her water gourd and the nigeo tree she grabbed, up into the sky. Her shadow can still be seen on the moon's face. These myths, from every corner of the world, show that humans have always projected meaning onto the moon. It's been a god, a goddess, an animal, a container for souls, a source of madness, a symbol of change, and a marker of time. The moon has been humanity's companion, witness, and muse for our entire existence. For centuries, people have believed the moon influences human behavior and emotion. The word lunacy comes from this belief. The idea that the moon, particularly the full moon, could drive people mad. Even today, some people believe that full moons cause increased crime, more births, more emergency room visits, or strange behavior. Hospital workers and police officers will sometimes tell you that full moon nights are busier and more chaotic. But what does the science say? Well, numerous rigorous studies have looked at these claims, and the evidence is remarkably consistent. There's no measurable increase in crime, accidents, psychiatric admissions, or births during full moons. The data simply doesn't support these beliefs. When researchers control for other factors like day of the week, season, and weather, the full moon effect disappears. So why do these beliefs persist? There are a few psychological explanations. One is confirmation bias. If you believe full moons cause strange behavior, you're more likely to notice and remember odd events that happen during a full moon, while forgetting the equally odd events that happen at other times. If a chaotic night happens to coincide with a full moon, you think, aha, I knew it. If a chaotic night happens during a crescent moon, you don't connect it to the moon at all. Over time, this selective memory reinforces the belief. Another factor is that the full moon is bright enough to notice, so people are more aware of when it's full than they are of the moon's other phases. This increased awareness makes the full moon seem more significant. That said, the moon definitely does affect some living things. Many marine creatures time their reproductive cycles to the moon. Corals, for instance, coordinate their spawning with specific lunar phases, releasing eggs and sperm simultaneously so that fertilization can occur. Some species of fish, crabs, and sea turtles also time their activities by the moon and tides. These behaviors make sense because the tides are directly caused by the moon, and for coastal creatures, tides are a dominant factor in their environment. Some land animals also show lunar rhythms. Certain insects are more active during particular moon phases. Some studies suggest that lion hunting success varies with lunar brightness. They're more successful during darker nights when they can approach prey more stealthily. Other research has found that some bird species time their migrations to avoid full moons, perhaps to reduce predation risk from nocturnal predators who would find them more easily in bright moonlight. And what about humans? While there's no evidence for the full moon causing madness or mayhem, our ancestors certainly organized their lives around lunar cycles. Human reproduction doesn't appear to be linked to the moon, despite the coincidence that the menstrual cycle averages about 28 days, similar to the lunar month. Statistical analysis shows no correlation between menstrual cycles and lunar phases across populations. It's likely just a coincidence, or perhaps both cycles are responding to some other fundamental biological rhythm. However, moonlight can affect human sleep, at least in the absence of artificial lighting. Some studies have found that people sleeping in conditions where moonlight can enter, such as camping, do sleep slightly less and less deeply during full moons. This makes evolutionary sense. Bright moonlight would have been useful for nighttime activities or watchfulness against predators, so perhaps our ancestors were more active during full moon nights. In our modern world, with electric lights far brighter than any moon. This effect has largely disappeared, but there's something in the human psyche that still responds to the moon. Maybe it's cultural memory, millennia of stories and beliefs embedded in our collective consciousness. Maybe it's simply the beauty of it, the way a full moon can transform a landscape, casting everything in silver, creating long shadows, making the familiar world feel dreamlike and magical. You can't measure that with statistics, but it's real nonetheless. On July 20th, 1969, humanity did something unprecedented. We left our planet and set foot on another world. When Neil Armstrong stepped off the ladder of the Apollo 11 lunar module and onto the dusty surface of the moon, he spoke words that have become iconic. That's one small step for man, one giant leap for mankind. Well, he actually said for a man, though the recording is a bit unclear. Regardless of the exact wording, the meaning was unmistakable. After billions of years of gazing up at the moon, we had finally touched it. The journey to that moment was extraordinary. The Apollo program was born from Cold War competition, but it became something more, a testament to human ingenuity, courage, and the desire to explore. Getting to the moon required solving thousands of engineering challenges. How do you build a rocket powerful enough to escape Earth's gravity? How do you navigate across 384,000 kilometers of space? How do you land safely on a surface you've only seen through telescopes? How do you keep astronauts alive in the hostile environment of space and the moon? Each question demanded innovation. The Saturn V rocket that carried Apollo missions to the moon remains the most powerful rocket ever successfully flown. It stood 110 meters tall, about the height of a 36-story building, and weighed 2,800 metric tons when fully fueled. At launch, its 5 first-stage engines produced 34 million newtons of thrust, equivalent to about 1.5 million horsepower. The noise was described as overwhelming, a physical sensation that shook your bones and chest even from kilometers away. And all that power was needed just to lift 3 men and their spacecraft away from Earth's grasp. The journey to the moon took about 3 days. The astronauts traveled in a tiny command module, about the size of a small van, with barely enough room for 3 people to exist. They had no privacy, no shower, no real comfort. They ate rehydrated food and drank recycled water. They urinated into bags and defecated into bags, experiences that were apparently just as unpleasant as they sound, and they did all this while hurtling through the vacuum of space at thousands of kilometers per hour, separated from instant death by a few centimeters of aluminum and a heat shield. When they reached the moon, 2 astronauts would transfer to the lunar module, while 1 remained in the command module, orbiting the moon alone. The lunar module, nicknamed the LM or LEM, was unlike any aircraft ever built. It didn't need to be aerodynamic, because there's no air on the moon. It looked spindly and fragile, with thin walls and insect-like legs, but it was engineered to perfection. It had 2 stages, a descent stage with landing legs and fuel tanks, and an ascent stage that would later launch the astronauts back to orbit. Landing on the moon was terrifying. The astronauts descended backward, unable to see where they were going, relying on radar and computer calculations. The computer had less processing power than a modern smartphone, but was programmed by some of the brightest minds of the time. During Apollo 11's landing, the computer became overloaded with data and triggered alarms. Mission Control had to quickly assess whether to abort or continue. They decided to continue. Then, with fuel running dangerously low, Armstrong took manual control because the computer was guiding them toward a boulder field. He piloted the LM to a smoother spot with just seconds of fuel remaining. When the probe on one of the landing legs touched the surface, a light illuminated on the control panel. Armstrong calmly announced, "Contact light." Then the engine stopped, and the LM settled onto the moon. The Eagle has landed. Walking on the moon was strange. The gravity is only 1/6 of Earth's, so everything felt lighter. The astronauts weighed only about 30 pounds in their spacesuits, even though the suit itself weighed about 180 pounds on Earth. They discovered that the most efficient way to move was a sort of loping hop, a gate that humans had never used before and have never used since, except on the moon. They described the surface as covered in a fine grey powder that kicked up around their boots but fell back immediately, without the air to keep it suspended. Their boot prints were sharp and clear, preserved in the dust, like prints in fresh snow. The sky above them was black, even in daylight, because there's no atmosphere to scatter sunlight and make it blue like on Earth. Stars were visible, though most astronauts reported they were too busy with their tasks to spend much time looking at them. Earth hung in that black sky, a beautiful blue and white marble, impossibly colorful against the void. Many astronauts said that seeing Earth from the moon was the most profound part of the experience, seeing our whole world as a fragile oasis suspended in darkness. The Apollo astronauts collected samples of lunar rock and soil, set up scientific instruments, took photographs, and planted the American flag, which was a specially designed flag with a horizontal rod to hold it out since there's no wind. They spent hours working on the surface, then climbed back into the LM, sealed the hatch, and tried to rest before the most dangerous part of the mission, launching from the moon. The LM's ascent engine had to work perfectly. There was no backup. If it failed, the astronauts would be stranded with no possibility of rescue. When the moment came, the engine fired, the descent stage served as a launch pad, and the ascent stage climbed back into orbit. Every time, it worked. The engineering was that good. Between 1969 and 1972, 12 American astronauts walked on the moon during 6 Apollo missions. Apollo 13 famously suffered an oxygen tank explosion and didn't land, but the crew returned safely in one of the most dramatic rescue missions in history. The other missions each added to our knowledge. Apollo 15, 16, and 17 brought lunar rovers, small electric cars that allowed astronauts to travel kilometers from their landing sites, greatly expanding the area they could explore. The astronauts brought back 382 kilograms of lunar samples, rocks, and soil that scientists are still studying today. These samples revolutionized our understanding of the moon. They confirmed the moon's ancient age, revealed its volcanic history, and provided evidence for the giant impact theory of the moon's formation. Some samples contained tiny glass beads, formed when meteorite impacts melted the soil and splash droplets solidified in flight. Others showed the effects of billions of years of radiation and micrometeorite bombardment. Each rock was a time capsule. Perhaps the most famous photograph from Apollo is Earthrise, taken by Apollo 8 astronaut William Anders during humanity's first orbit of the moon on Christmas Eve 1968. The image shows Earth rising above the stark lunar horizon, our planet vibrant with blues, whites, and browns against the black sky and grey moon. The photograph became an icon of the environmental movement, a reminder of how precious and isolated our home is. After Apollo 17 in December 1972, humans haven't returned to the moon. For over 5 decades, the moon has been unvisited by human feet, though not by our robots and imaginations. Many people wonder why we stopped. The reasons are complex. The program was expensive, the political will faded after the initial space race victories, and public interest waned once the novelty wore off. Some critics argued the money would be better spent on problems at home. Others felt we'd accomplished what we set out to do. But the Apollo missions left a permanent mark on human consciousness. We had extended our reach beyond our planet. We'd stood on another world and looked back at our own. The technology developed for Apollo found its way into everyday life. Advancements in computing, materials, science, telecommunications, and more. And the dream of returning to the moon, or going beyond to Mars and the asteroids, has never died. New missions are being planned by space agencies and private companies. Perhaps within the next decade, humans will walk on the moon again, and this time maybe we'll stay. In recent years, spacecraft from several countries have confirmed something that scientists long suspected but couldn't prove until recently. There's water on the moon, not liquid water, of course. The moon's surface is far too hostile for that, but water ice, hiding in the shadows. The discovery began with orbital observations. Spacecraft equipped with spectrometers detected the spectral signature of water molecules in lunar soil, particularly near the poles. Then in 2009, NASA deliberately crashed the LCROS spacecraft into a permanently shadowed crater near the Moon's south pole, while another spacecraft flew through the debris plume and analyzed it. The results were striking. The plume contained water vapor and ice, along with other volatile compounds. There was water in that crater, and quite a bit of it. How did water get there? The Moon seems like the last place you'd find water. It has no atmosphere, no oceans, no rain. Water exposed to sunlight would quickly break apart or evaporate into space. But the Moon's poles are different. Some craters near the poles are so deep and their walls so high that sunlight never reaches their floors. These permanently shadowed regions are some of the coldest places in the solar system, colder than the surface of Pluto, with temperatures around -230 degrees Celsius. In these frozen shadows, water ice can persist for billions of years, a cold trap where molecules that normally wouldn't survive can accumulate. Where did the water originally come from? Likely from multiple sources. Comets and asteroids, many of which contain ice, have been striking the Moon for billions of years. Some of that water would vaporize on impact, but some could migrate to the cold traps and freeze there. Additionally, the solar wind, which is actually a stream of charged particles from the Sun, includes hydrogen ions. When these hydrogen ions strike oxygen atoms in lunar soil, they can combine to form water molecules. Over billions of years, this process could create a significant amount of water, spread thinly across the lunar surface, but concentrated in those eternally dark craters. Why does this matter? For future lunar explorers, water is incredibly valuable. It's heavy to transport from Earth, and you need a lot of it. Humans require water for drinking, of course, but also for hygiene, growing food, and as a radiation shield. Even more importantly, water can be split into hydrogen and oxygen, which are rocket fuel. A lunar base with access to water ice could refuel spacecraft without needing to bring fuel from Earth, making the Moon a potential stepping stone for deeper space exploration. Water turns the Moon from a dead, useless rock into a potentially habitable place with resources that could support human presence. Some scientists now talk about lunar bases not as science fiction, but as engineering challenges to be solved. How do you extract ice from the soil? How do you process it? How do you store it? These are difficult questions, but not impossible ones. Several space agencies and private companies are actively planning missions to the Moon's south pole to prospect for water and demonstrate extraction technologies. Beyond water, the Moon has other resources. The soil, called regolith, contains oxygen bound in mineral form. If you can extract that oxygen, you have air to breathe and rocket oxidizer. The regolith also contains metals like iron, aluminum, and titanium. It could potentially be used to construct buildings and tools, though working with it would require new industrial processes adapted to the lunar environment. There's also helium-3, a rare isotope that's embedded in the lunar soil by the solar wind. Helium-3 is extremely rare on Earth, but relatively common on the Moon, because Earth's magnetic field and atmosphere shield us from the solar wind, while the Moon has no such protection. Some scientists speculate that helium-3 could be valuable for future fusion reactors, though fusion power is still experimental, and we don't know if helium-3 fusion will ever be practical. Still, it's an intriguing possibility. The Moon also offers advantages simply by being the Moon. Its gravity, while low, is enough to make working there easier than in zero gravity. Building structures is possible. Liquids pour, dust settles instead of floating everywhere. At the same time, the low gravity makes launching spacecraft much easier than from Earth. A rocket leaving the Moon needs far less fuel than one leaving Earth. The Moon has no atmosphere to fight through, and no thick blanket of air to create drag or weather to delay launches. Some visionaries imagine the Moon as a manufacturing hub, a place where large space structures could be built from lunar materials and launched without the enormous energy cost of escaping Earth's gravity. Others see it as a laboratory for science, a place to study the early solar system through ancient lunar rocks, or to build telescopes on the far side, shielded from Earth's radio noise. And some simply see it as humanity's next frontier, a place to go because we can, because exploring and expanding is what humans do. Remember earlier, when we mentioned the moon is gradually moving away from Earth? Let's revisit that phenomenon and think about its implications. The moon is receding at about 3.8 centimeters per year, a rate we can measure with extraordinary precision using laser ranging. Astronauts from Apollo missions placed retroreflectors on the lunar surface, special mirrors designed to reflect light directly back toward its source. Scientists on Earth can aim powerful lasers at these mirrors and measure the time it takes for the light to return. Since light travels at a known constant speed, timing the round trip tells you the distance. By repeating this measurement over years and decades, scientists have detected the moon's gradual retreat. Why is this happening? As we discussed, it's because of tides. Earth's rotation is gradually slowing down due to tidal friction, and that rotational energy has to go somewhere. It's transferred to the moon, increasing the moon's orbital energy and causing it to spiral outward, very slowly, into a higher orbit. This process has been ongoing since the moon formed, which is why the moon was so much closer billions of years ago. If we extrapolate forward, we can ask, will the moon ever leave Earth entirely? The answer is no, not through this mechanism. The process will continue until Earth's rotation slows down enough that one Earth day equals one lunar month. At that point, Earth will be tidally locked to the moon, and the tidal bulges will no longer move relative to Earth's surface, so there'll be no more tidal friction to transfer energy. Calculations suggest this would happen when the day length reaches about 47 of our current hours, and the moon would be about 40% farther away than it is now. However, this equilibrium won't actually be reached, at least not before something else happens. The sun is gradually getting brighter as it ages, a normal part of stellar evolution. In about 1 billion years, Earth will become too hot for liquid water to exist on the surface. In about 5 billion years, the sun will expand into a red giant, possibly engulfing Earth entirely, or at least making both Earth and Moon uninhabitable. So the Moon's outward drift will be interrupted by the Sun's changes long before Earth and Moon reach tidal equilibrium. It's a reminder that nothing in the cosmos is truly permanent. Looking backward in time, we can calculate that the Moon was much closer in the past. About 2.5 billion years ago, the Moon was perhaps 60,000 kilometers closer, and a day on Earth was only about 18 hours long. Go back 4 billion years, and the Moon might have been only 150,000 kilometers away, appearing several times larger in the sky, and days were just a few hours long. The tides would have been enormous, perhaps hundreds of meters high in some places, reshaping coastlines constantly. This has implications for Earth's history. Those massive ancient tides would have created intense mixing in the oceans, cycling nutrients and maintaining chemical gradients that might have been important for early life. The shorter days would have meant more rapid temperature fluctuations, different weather patterns, and a faster rotating atmosphere. Earth's magnetic field, which is generated by the churning molten metal in our planet's core, might have been different in strength or configuration. The Moon's changing distance has shaped not just our nights, but the entire evolutionary history of our planet. It's humbling to think that the Moon we see today is not the Moon that dinosaurs saw, or that the first fish saw, or that the first bacteria existed under. The Moon's relationship with Earth is dynamic, evolving, a slow dance that's been changing tempo over billions of years. As our journey through the world of the Moon begins to wind down, it's worth reflecting on what the Moon means to us. Beyond the science and the facts, the Moon is our companion, the only celestial body close enough that we can see details with our unaided eyes. It's been with Earth for almost the entire history of our planet, a silent witness to everything that's happened here. It saw the first oceans form, the first life emerge, the first creatures crawl onto land. It watched the dinosaurs rise and fall. It illuminated the first humans as they learned to make fire, paint on cave walls, build civilizations. The moon has been constant through all of human history, a reliable presence in the night sky, while kingdoms rose and fell, while languages were born and died, while our species spread across the planet and developed the technology to finally reach back and touch our ancient companion. Every person who has ever lived has looked up at the same moon, seen the same patterns, wondered the same questions. That's a profound connection across time and culture. The moon reflects our light back to us, literally and metaphorically. Moonlight is sunlight that's touched the moon and bounced back to Earth, but in doing so it's changed, softened, made gentle. In the same way, the moon reflects our aspirations and dreams. We've projected our myths onto its surface, used it to measure our time, made it the subject of countless poems and songs and paintings. The moon is a mirror for human imagination, and it's a reminder of perspective. When the Apollo astronauts looked back at Earth from the moon, they gained a view that no human had ever had before. Earth, seen from afar, looked fragile and beautiful, a tiny oasis in the vast emptiness of space. The photographs they took, that Earthrise image, and the blue marble photo of the full Earth, changed how we see ourselves. The environmental movement draws inspiration from those images, from the visceral understanding that we all share one small planet, that there are no borders visible from space, that Earth is precious and vulnerable. The moon taught us that we can go beyond our world. The Apollo program proved that with enough dedication, ingenuity, and courage, humans can accomplish things that seem impossible. We visited another world and returned safely. We left footprints on alien soil. If we can do that, what else might we achieve? The moon missions inspired generations of scientists, engineers, and explorers. Many people working in space programs today were children when they watched those grainy black and white images of astronauts bouncing across the lunar surface, and they decided then and there what they wanted to do with their lives. The moon also teaches patience. It changes every night, but the changes are gradual, predictable, part of a cycle that repeats month after month, year after year, millennium after millennium. In our fast-paced modern world, there's something calming about watching the moon go through its phases, a reminder that some things happen on their own schedule, that nature has rhythms that can't be rushed. Stand outside on a clear night when the moon is visible. Really look at it. Notice the patterns of light and dark. Think about what you're seeing: ancient lava flows, impact craters billions of years old, a surface that's remained virtually unchanged for eons. Think about the fact that the light reaching your eyes left the sun 8 minutes ago, bounced off the moon a second and a quarter ago, and is now being focused by your eye's lens onto your retina, triggering chemical reactions that your brain interprets as sight. You're seeing across space and time, connected by photons to a world 384,400 kilometers away. Think about the fact that the moon's gravity is pulling on you right now, ever so slightly, the same way it pulls on the oceans. You're too small and solid to feel it, but it's there, a cosmic connection. You and the moon are in gravitational conversation, each pulling on the other. The moon shapes the tides, and the tides shape the coasts, and the coasts shape ecosystems, and ecosystems shape evolution. And here you are, a product of billions of years of evolution, on a planet shaped by its moon, looking up at that very moon. It's a circle, a loop, a connection that ties you to the cosmos. The moon reminds us that we're part of something larger. Earth is not alone. We have a companion, born from violence, but enduring in peaceful orbit, a fragment of our own planet that became a separate world, a mirror, a timekeeper, a destination, a symbol. The moon has shaped our planet, our evolution, our cultures, and our dreams. In recent years, there's been renewed interest in returning to the moon, and not just for brief visits. Space agencies from multiple countries are planning lunar missions. NASA's Artemis program aims to land humans on the moon again, including the first woman and the first person of color to walk on the lunar surface. The plan goes beyond planting flags and collecting samples. The goal is to establish a sustained presence, a base camp that can support long-duration missions. The Artemis program envisions a small space station called Gateway that would orbit the Moon, serving as a staging point for surface missions. Astronauts would travel from Earth to Gateway, then transfer to a lunar lander for the journey to the surface. Unlike Apollo, which landed in relatively flat equatorial regions, Artemis aims for the Moon's south pole, where those permanently shadowed craters with water ice reside. Establishing a presence near these ice deposits could provide the resources needed for longer stays. Other countries are also planning lunar missions. China has already landed robotic spacecraft on the Moon's far side, an impressive technical achievement since communication with the far side requires a relay satellite. China has stated ambitions to send astronauts to the Moon in the coming decades. India has sent successful orbiter and lander missions. The European Space Agency has proposed building an international moon village, a permanent base where multiple countries could conduct research and develop lunar resources. Russia and China have announced plans to collaborate on a lunar base. Private companies like SpaceX are developing heavy-lift rockets that could make lunar missions more affordable. This new era of lunar exploration feels different from Apollo. The first time, it was a race, driven by Cold War competition and national pride. This time, it seems more cooperative, more international, and more focused on permanence rather than brief visits. The vision is of the Moon as a destination where people will live and work, not just visit and leave. What would life on a lunar base be like? It would be challenging, certainly. You'd live in a pressurized habitat, probably partially buried under regolith to shield you from radiation and micrometeorite impacts. The sun shines constantly for about 2 weeks, then it's night for 2 weeks, except in certain polar locations where peaks remain sunlit for most of the year, the so-called peaks of eternal light. These locations are prime real estate for solar panels. You'd have to wear a spacesuit for any excursions outside, and those suits would need to be much more durable than the Apollo suits, which were only designed for a few days of use. Working in lunar dust would be a constant challenge. Growing food would likely happen in greenhouses, with LED lights providing energy for photosynthesis and careful recycling of water and nutrients. But there would be compensations. The low gravity might be fun once you got used to it. Imagine being able to jump meters into the air with minimal effort. Construction would be easier because everything weighs 1/6 of what it does on Earth. The views would be spectacular. Earth hanging in the black sky, stars unobscured by any atmosphere, the stark beauty of the lunar landscape. And you'd be a pioneer, part of humanity's expansion beyond Earth. That sense of purpose, of being involved in something historically significant, might outweigh the hardships. The first lunar settlers would be explorers in the truest sense, venturing into a new world and figuring out how to make it habitable. Some people wonder whether we should go to the Moon at all. Couldn't the money be better spent on problems here at home? It's a fair question, and there's no simple answer. The counterargument is that space exploration has historically driven innovation that benefits everyone. The technologies developed for space have applications on Earth. Studying other worlds helps us understand our own better, and there's something valuable, perhaps even necessary, in having ambitious goals that inspire people and push the boundaries of what's possible. There's also the long-term survival argument. Earth is a wonderful home, but it's not invulnerable. Asteroid impacts, supervolcano eruptions, pandemics, climate change, or other catastrophes could threaten our civilization or even our species. Having humans living on multiple worlds provides a backup, a way to ensure that some human culture and knowledge survives even if something terrible happens to Earth. It's thinking on timescales of centuries or millennia rather than years or decades. But beyond practical arguments, there's something deeper. Humans are curious by nature. We explore because that's what we do. Our ancestors walked out of Africa and spread across every continent. They crossed oceans on tiny boats to reach islands they couldn't see from shore. They climbed the highest mountains, explored the deepest caves, ventured to the poles. They crossed oceans on tiny boats to reach islands they couldn't see from shore. They climbed the highest mountains, explored the deepest caves, ventured to the poles. Exploration is woven into our DNA. The moon is simply the next horizon. And perhaps we explore not just for practical reasons, but for beauty, for wonder, for the sheer joy of discovery. There's value in standing somewhere no one has stood before, in seeing something no one has seen, in asking questions no one has asked. The moon calls to us not because it's useful, though it might be, but because it's there, mysterious and beautiful and waiting. When you think about it, the moon is a paradox. It's completely familiar, something we see regularly and take for granted, yet it's also utterly alien, a world where nothing lives, where the sky is black and the horizon is much closer than on Earth, because the moon is so much smaller, a place where your weight would change but your mass wouldn't, where sounds don't travel because there's no air, where temperatures swing wildly from boiling to freezing. The moon is close enough that we visited it, yet far enough that only 12 humans out of the roughly 100 billion who have ever lived have walked on it. It's been studied intensely, yet still holds mysteries. We know the composition of its rocks, but debate how it formed. We've mapped its surface in exquisite detail, but are still discovering new things, like those ice deposits in polar craters. The moon is ancient, nearly as old as Earth itself, yet it also represents the future, humanity's next destination, and perhaps eventual home. It's a place of extremes, bathed in radiation, airless and waterless on the surface, yet potentially harboring resources that could support life in protected habitats. The moon is scientific and poetic, a subject for orbital mechanics equations and romantic sonnets. It's been worshipped as a deity and visited in a spacecraft. It's inspired fear and comfort, myths and missions. It's a rock and a symbol, a world and a metaphor. There's something about the moon that touches something deep in the human psyche. Maybe it's because the moon is always changing yet always the same, waxing and waning but never disappearing entirely, always returning. That cycle of change and renewal resonates with us. Life is full of cycles, seasons, phases. The moon reminds us that change is natural and that after darkness comes light again. Or maybe it's because the moon is solitary, one satellite orbiting one planet, a companion rather than a crowd. Earth could have multiple moons like Mars, or a spectacular ring system like Saturn, but instead we have one moon, singular and special. That relationship feels personal somehow. Earth and moon, a partnership that's lasted billions of years. Or maybe we simply love the moon for its beauty. There's something undeniably beautiful about moonlight, about the way it transforms landscapes into something dreamlike. Colors fade, but shapes become sharper. Shadows deepen. Everything takes on a silvery quality that's different from daylight or artificial light. Moonlight is natural but feels magical. Poets have tried for millennia to capture what moonlight does, how it makes the familiar world strange and the strange world familiar. Moonlight makes us contemplative, thoughtful, perhaps because it's gentle enough to see by, but dim enough that we can also see the stars. Under the moon, we're reminded of the cosmos, of the vast universe beyond our immediate concerns. The moon has witnessed every moment of human history without judgment or interference. It shone on ancient Sumerians writing the first texts, on Egyptian pharaohs building pyramids, on Chinese emperors and Roman senators, on medieval monks copying manuscripts, on artists painting masterpieces, on scientists making discoveries, on ordinary people living ordinary lives. It shone on battlefields and on lovers embracing, on births and deaths, on triumphs and tragedies. The moon has seen it all and continues silently in its orbit, patient and eternal. In a way, the moon is the ultimate witness to the human story. Long after individual humans are forgotten, long after civilizations rise and fall, long after languages evolve or die out, the moon will still be there, circling Earth in that same patient rhythm. There's comfort in that constancy. It suggests that some things endure, that not everything is temporary and fleeting. But the moon also reminds us of impermanence. Those craters on its surface, those scars, are impact sites where asteroids and comets ended their journeys. Each crater represents a moment of tremendous violence frozen in time. The moon's surface is a museum of destruction, a reminder that the universe can be harsh and unforgiving, yet the moon endures. It's been struck countless times but remains whole, continues its orbit, continues to shine. Perhaps that's another lesson from the moon: resilience. The moon has been through catastrophic events, from the giant impact that formed it to billions of years of bombardment, but it's still here, still beautiful, still pulling at our oceans and our imaginations. There's something inspiring about that endurance. As we think about returning to the moon, we might consider what we want to bring with us and what we want to leave behind. The Apollo astronauts left flags, footprints, scientific instruments, and various pieces of equipment. They also left plaques with messages. The one from Apollo 11 reads, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." It's a beautiful sentiment, the idea that going to the moon was an achievement for all humans, not just one nation. Future lunar visitors will leave their own marks, build their own structures, create their own stories, but hopefully they'll also bring that same spirit, the idea that exploring space is a collective human endeavor that transcends national boundaries and political divisions. The moon doesn't care about our earthly conflicts, it just is. A world waiting to be understood and perhaps eventually inhabited. One of the interesting questions about future lunar settlements is what culture will develop there. If people live on the moon for extended periods, will they develop their own identity, separate from Earth? Will there be lunar traditions, lunar art, a lunar way of seeing the world? It's fascinating to think about. The moon's environment is so different from Earth's that it would inevitably shape the people living there in profound ways. Imagine growing up on the moon. You'd be used to 1/6 gravity, used to seeing Earth hanging in the black sky, used to long days and long nights, used to living in enclosed habitats and suiting up to go outside. When you eventually visited Earth, assuming you could adapt to the stronger gravity, everything would seem heavy and strange. The blue sky would be bizarre after the black lunar sky. Rain would be a miracle. The ocean would be overwhelming. All that water moving in tides that you'd know intellectually were caused by your home, but which you'd never experienced. Birds flying would be astonishing. Life moving freely through the air without suits or protection. On the flip side, returning to the moon after visiting Earth would bring its own relief. The familiar low gravity, where you can move easily. The sight of home, that small world that you know intimately. The quiet, because on Earth, there's constant sound from wind, animals, human activity, whereas on the moon, outside sounds don't exist. And even inside habitats would be quieter than Earth cities. Would lunar settlers long to return to Earth permanently, or would they feel the moon was truly home? It's an open question, one that won't be answered until we actually establish long-term lunar habitats. But it's worth pondering, because it gets at something fundamental about what makes a place home. Is it where you were born, where you feel comfortable, where your community is, where you choose to be? The moon might become home for some humans, just as Antarctica is home for researchers who winter over. Even though it's harsh and isolated, people are adaptable. We can make homes in deserts, in Arctic regions, on remote islands, in mountains. The moon would be more challenging than any of these, but not necessarily impossible. With the right technology and sufficient motivation, humans could live there, work there, maybe even thrive there. And if that happens, the moon will transition from being a destination to being a place, from being out there to being simply another location where humans live, as real and concrete as any city or village on Earth. That would be a profound shift in human civilization, the first time we've become a truly multi-world species. But even if that future comes to pass, even if lunar cities are built and thousands of people live and work on the moon, it will still be special to those of us on Earth. It will still be the moon, that bright circle in our night sky, that ancient companion. We'll still watch it go through its phases, still feel a sense of wonder when we see it rising over the horizon, because the moon is more than a rock orbiting Earth. It's part of our story, part of our identity as a species. Think about all the words and phrases in our language that reference the moon. Once in a blue moon for something rare, over the moon for being extremely happy, mooning over someone you love, moonlighting for working a second job, honeymoon for a couple's first trip together. The moon is embedded in how we talk, how we think, how we understand the world. Think about all the songs about the moon: Fly Me to the Moon, Moon River, Blue Moon, Shine on Harvest Moon, Bad Moon Rising, Dancing in the Moonlight, Walking on the Moon, and countless others. Every musical tradition has moon songs because the moon speaks to something universal in the human experience. Think about all the paintings and photographs of the moon. Artists have tried to capture its light, its presence, its mystery for as long as art has existed. From ancient petroglyphs showing the moon to Renaissance paintings featuring moonlit scenes to modern photographs from spacecraft showing the lunar surface in stunning detail, the moon has been an endless source of artistic inspiration. The moon appears in literature from the earliest epics to modern novels. It's been a setting, a symbol, a character, a plot device. It represents mystery, romance, madness, change, femininity, nature, time, and 1,000 other things depending on the story. Writers return to the moon again and again because it's rich with meaning and association. Even in our secular, scientific age, the moon retains a kind of magic. We understand what it is, how it formed, why it shines, how it affects the tides. We've visited it and brought back pieces of it to study. We've mapped every square meter of its surface, yet none of that knowledge diminishes the moon's beauty or its ability to move us emotionally. If anything, understanding the moon makes it more wondrous, not less. Knowing that the light touching your face left the sun, traveled 150 million kilometers to the moon, bounced off ancient rock, traveled another 384,400 kilometers to Earth, and entered your eye, doesn't make moonlight less magical, it makes it more so. You're connected by photons to both the sun and the moon, part of a cosmic conversation happening at the speed of light. Knowing that the moon's gravity is pulling at you right now, that you're in gravitational embrace with a world 384,400 kilometers away, doesn't diminish the moon's mystery, it deepens it. You're part of a system, Earth and moon dancing through space together, and that dance creates the tides, stabilizes Earth's climate, and may have helped life emerge and evolve. Knowing that the moon formed from a catastrophic collision, that it's made of Earth's own substance, that it's literally a piece of our planet that broke away and became its own world, doesn't make the moon less poetic. It's an origin story of cosmic violence giving birth to beauty, of destruction creating something that would endure for billions of years. What myth could be more powerful than that? As we near the end of our journey through the world of the moon, let's take a moment to simply appreciate it. The moon has been with us in these last hours as surely as it's been with Earth for billions of years. We've traveled from its violent birth in the debris of a planetary collision, through its long history of impacts and volcanic eruptions, through the development of its features and its slow drift away from Earth. We've explored how it affects our planet, creating tides and stabilizing our rotation. We've looked at how humans have viewed the moon, from ancient myths to modern missions. We've considered its resources and its potential as a future home. And through it all, the moon has remained what it's always been: mysterious, beautiful, and endlessly fascinating. The moon teaches us about time, geological time, where millions of years are meaningful units, and a billion years is a chapter in a story. Seeing moon rocks that formed before life existed on Earth gives us perspective on how recent we are, how brief human history is compared to the age of the solar system. Yet those ancient rocks will still be there long after we're gone, silent and patient, waiting for the sun to die, or for some other end to come. The moon teaches us about change. The phases remind us that change is cyclical, that dark periods are followed by light, that nothing stays the same but patterns repeat. The moon's slow drift away from Earth reminds us that even seemingly eternal relationships change over time, though some changes are so gradual we barely notice them in a human lifetime. The moon teaches us about perspective. Seeing Earth from the moon changed how astronauts viewed our planet, revealing it as a fragile oasis rather than an infinite resource. Sometimes you need distance to truly see something, to understand what matters and what's precious. The moon teaches us about exploration and curiosity. We went there because we wondered what it was like, because we wanted to know, because it was there. That impulse to explore, to seek understanding, to venture beyond the known, is fundamentally human and fundamentally valuable. The moon teaches us about beauty. Not everything has to have a purpose or a use to be worthwhile. Sometimes beauty is enough. Moonlight is beautiful. Moonrise is beautiful. The moon's face is beautiful. That beauty has enriched human life for as long as humans have had eyes to see. That's not a small thing. So as you drift off tonight, imagine the moon above you. Maybe it's visible right now, shining through your window or hidden behind clouds. Maybe it's on the other side of Earth from you, illuminating someone else's night. Either way, it's there, right where it always is, following its ancient path around our planet. Imagine that pale light filtering through space, crossing the void between moon and Earth in just over a second, light that left the sun 8 minutes ago and bounced off rocks older than any life on Earth. Imagine the moon's gravity reaching across that vast distance, pulling at the oceans, creating the rhythm of the tides that's been constant for billions of years. Imagine the footprints still there on the lunar surface, preserved in dust because there's no wind or water to erase them, evidence that humans once walked on another world and returned to tell the tale. Those footprints will last for millions of years, far longer than any monument or building on Earth, silent testimony to human achievement and courage. Imagine future explorers returning to the moon, landing near those old Apollo sites, looking at the equipment left behind, and the footprints still crisp and clear after decades or even centuries. Imagine them building new habitats, growing the first lunar gardens, extracting water from frozen craters, looking up at Earth in the black sky, and feeling both homesick and at home. Imagine the moon continuing its patient orbit, day after day, year after year, millennium after millennium, slowly spiraling outward at the pace of growing fingernails, watching Earth as it always has, witness to everything that happens on our planet. Imagine it shining on ancient forests and future cities, on primitive microbes and advanced civilizations, on the first life and perhaps the last, constant and changing, familiar and mysterious. The moon is a world in its own right, with its own geology, its own history, its own features and characteristics. But it's also part of Earth's story, born from Earth, shaping Earth, connected to Earth through gravity and light and shared history. We are Earth and Moon, two worlds in partnership, dancing through space together. And as you close your eyes, as sleep comes gently like moonlight through a window, know that the moon is still there, still circling, still shining. It was there before you were born and will be there long after you're gone. It shone on your ancestors and will shine on your descendants. It's one of the few truly permanent things in a world of change. The moon asks nothing of us. It doesn't need our attention or our appreciation. It would continue its orbit whether we noticed it or not, whether we understood it or not, whether we valued it or not. But we do notice, we do understand, at least a little, and we do value it. We look up at the moon and feel connected to something larger than ourselves, something ancient and enduring. There's comfort in that. Whatever challenges you face, whatever worries keep you awake, whatever problems seem overwhelming, the moon reminds you that there's a larger context. You're part of a system that includes planets and moons, oceans and tides, the pull of gravity across millions of kilometers of space. You're made of atoms forged in stars, living on a planet orbiting a star, looking at a moon that formed from a cosmic collision. You're part of the universe's story, a brief but genuine part. The moon has witnessed everything. It's seen every triumph and every tragedy, every birth and every death, every act of kindness and every act of cruelty that's ever happened on Earth. And it continues, unchanged by what it witnesses, serene in its orbit. There's a kind of wisdom in that detachment, a reminder that the universe is larger than our immediate concerns, that time passes and things change, and the cosmos goes on. But the moon also connects us to each other. Everyone sees the same moon, no matter where they are on Earth. the same phases, the same face, the same ancient companion. Right now, someone somewhere is looking at the moon and feeling what you feel when you look at it: wonder, peace, curiosity, connection. The moon is shared heritage, shared experience, something that belongs to all of us and to none of us. As you drift deeper now, letting go of the day, releasing whatever tensions you've been carrying, imagine yourself floating weightless, not in the blackness of space, but in the gentle grey light of the moon's embrace. Imagine the quiet there, the absolute silence where no sound travels because there's no air. Not an oppressive silence, but a peaceful one, a stillness that lets you hear your own thoughts clearly. Imagine looking back at Earth from that vantage point, seeing our whole world as a blue and white marble, beautiful and fragile, your home seen from the ultimate perspective. All the places you've been, all the people you know, everything you've ever experienced, all contained on that small sphere. It would make your problems seem smaller, perhaps, but your life no less valuable. Each life is brief in cosmic time, but precious precisely because it's brief, a unique pattern of experience and consciousness that will never be exactly repeated. The moon doesn't judge, it doesn't compare, it simply is, and in being, it offers us reflection, both literal and metaphorical. It reflects sunlight back to Earth, giving us gentle illumination in the darkness, and it reflects our own humanity back to us, showing us our dreams, our stories, our capabilities, our drive to explore and understand. So rest now, knowing the moon is there. Let its gentle light, whether real or imagined, soothe you. Let the knowledge of its ancient presence comfort you. Let the understanding of its continuing orbit, its patient journey around Earth, remind you that some things are reliable, enduring, and constant, even in a changing world. The moon has been humanity's companion for all of human history and all of prehistory before that. It watched the first hominids look up and wonder what that bright thing in the sky was. It watched us develop language, culture, civilization. It watched us figure out its nature, understand its motions, predict its phases. It watched us reach out across the gulf of space and finally touch it, and it will watch whatever comes next, whatever future humans create, wherever we go. You are part of that story. Your life, however ordinary it might seem, is part of the vast human story that unfolds beneath the moon's gaze. You are connected through time to every human who has ever looked up at the moon and wondered. You are connected through space to every person alive today who sees the same moon you see. You are connected through the physical reality of gravity and light to the moon itself, to Earth, to the sun, to the cosmos. These connections are real, not metaphorical. The moon's gravity is pulling on you right now. The atoms in your body were forged in ancient stars. You are literally made of stardust, living on a planet orbiting a star, looking at a moon made from your planet's own substance. You are not separate from the universe. You are part of it, as much a part of it as the moon, as much a part of it as anything that exists. And in that understanding, maybe there's peace. You don't have to carry everything alone. You're held by gravity, illuminated by light, part of systems and cycles and patterns larger than yourself. You can rest in that knowledge. You can let go, knowing that the universe continues whether you're awake or asleep, whether you're worried or calm, whether you're struggling or at peace. The moon continues its orbit, Earth continues its rotation, the sun continues its fusion reactions. The tides continue their eternal rhythm, in and out, high and low, pulled by the moon's gravity in a dance that's been happening for billions of years and will continue for billions more. You can trust in that continuity. You can rest in that reliability. So let yourself rest now, really rest. Let your breathing slow and deepen. Let your muscles relax, starting from your toes and moving up through your body, releasing tension you didn't even know you were holding. Let your mind quiet, thoughts becoming fewer and farther between, like stars appearing one by one as twilight deepens into night. Imagine the moon above you, whether you can see it or not, that pale companion keeping its eternal watch. Imagine its light, soft as silk, gentle as a whisper, falling on you wherever you are. Imagine that you're safe, held by the earth beneath you, and watched by the moon above you, cradled between two ancient worlds in a moment of perfect peace. The day is done. Whatever happened is now in the past. Tomorrow hasn't arrived yet. This moment, right now, is all there is. And in this moment, you are safe, you are whole, you are enough. The moon isn't judging you. The earth isn't testing you. The universe isn't demanding anything. You can simply be, simply rest, simply let go. Let go of the worries that chased you through the day. They'll still be there tomorrow if you need them. But right now, you don't. Right now, you can release them. Let them float away like leaves on a stream, drifting off into the darkness while you remain here, still and calm and peaceful. Let go of the things you didn't finish, the tasks still waiting, the messages unreturned, the decisions unmade. They'll be there tomorrow. Tonight, you need nothing but this breath, quiet, rest, peace. The moon doesn't hurry. The tides don't rush. Time passes at its own pace. Regardless of what you do, you can move with it rather than fighting against it. Let go of the past, at least for tonight. Whatever regrets you carry, whatever might have beens, whatever old hurts or disappointments, set them down gently and step away. They're not gone forever. If you want to pick them up again tomorrow, you can. But for now, for these hours of sleep, you don't need to carry them. Be free of them. Be light without them. Let go of the future too. Whatever you're hoping for, whatever you're dreading, whatever might happen or might not happen, it's all uncertain and unknowable anyway. The moon doesn't worry about where it will be in 1,000 years. It simply follows its orbit, moment by moment, in the eternal now. You can do that too. You can be here now, breathing, resting, just existing without purpose or plan. The moon is singing to you, though it makes no sound. It's singing the song of patience, of endurance, of ancient rhythms and reliable patterns. It's singing the song of light in darkness, of companionship in the void, of beauty that needs no justification. Can you hear it? Not with your ears, but with something deeper, some part of you that recognizes truth when it encounters it. You are stardust temporarily arranged in a pattern that can think and feel and wonder. The atoms that make up your body have existed since the beginning of time and will continue to exist after you're gone, rearranged into new patterns, new forms, new experiences. Energy cannot be created or destroyed, only transformed. You are a transformation of the universe's energy, a way the cosmos has organized itself to be conscious, to observe itself, to know itself. And tonight, right now, that consciousness is tired. It needs rest. It needs to dim like the moon waning, to retreat into darkness, not as an ending, but as part of a cycle, because rest allows for renewal and darkness makes light possible. You cannot always be full moon, blazing with light. Sometimes you need to be new moon, hidden and resting, gathering your energy for the next cycle. So rest. Let sleep come like the tide coming in, inevitable and natural, gentle waves of drowsiness, lapping at the shore of consciousness, until finally you slip beneath the surface into the deep, quiet ocean of sleep. There's nothing to fight, nothing to resist. Sleep is natural, sleep is healing, sleep is what your body needs, and you can trust your body, it knows what to do. The moon keeps watch while you sleep. It's been keeping watch for 4.5 billion years. It won't stop now. You are safe to let go, safe to drift, safe to sleep deeply and peacefully, knowing that the world continues, the universe endures, and morning will come in its time, gentle and inevitable as moonrise. Thank you for joining me on this journey through the world of the moon. Thank you for your time, your attention, your willingness to wonder about this ancient companion that shares our sky. May you sleep peacefully under the moon's gentle gaze, and may you wake tomorrow with the same sense of wonder and connection that has drawn humans to the moon since the dawn of time. The moon is there, you are here, and both of those things are exactly as they should be. Good night, traveler. Rest well. The moon watches over you as it always has, as it always will, patient and eternal and beautiful in the darkness.